watching this free video tutorial from MographPlus.com. If you are interested in learning Arnold 5 for Maya fundamentally, please make sure to check out our comprehensive Introduction to Arnold 5 for Maya course, which is a massive 9-hour long course in which we explore all the aspects of Arnold for Maya thoroughly. Hey folks, how you doing? In this tutorial, we learned how to create the dragon shader in Arnold for Maya. By dragon shader, I mean this jade-like shader that we see in this render, where the thicker parts of the model having more subsurface scattering quality and the thinner parts are more refractive and transmissive. Also, we have this beautiful color contrast between the thin and the thick parts of the model, and we have control over a lot of aspects of this shader once we create it: the color, the amount of subsurface scattering and transmission, the contrast, and so many other things. And a lot of it will be done in the transmission section of the Arnold standard surface shader. I suggest you take a look at our comprehensive Introduction to Arnold 5 for Maya course at MographPlus.com and learn the ins and outs of the standard surface shader before watching this video. Now let's get back to Maya and see what we have here. First, let's adjust the UI a bit and make more space. From the window menu, open up the preferences window. Go to the UI elements section and hide the shelf, time slider, range slider, command line, and help line. Now open up the Arnold render view from the Arnold menu and dock it on top of the viewport. In this scene, we have this dragon model and this backdrop geometry and a few lights. You can download the project file using the link down below in the description. The dragon model that we have here is from 3dscans.com. Let's run the IPR and make sure we are using our main camera to render. Now go to the perspective view and let's take a quick look at the lighting setup that we have. There are 4 lights in the scene. This is our main light, which is placed behind the subject, and this way we can see the scattering quality of the shader much better. We have this backlight, which is placed on the right side of the model and acts as a fill light. We have this front light as a secondary fill light for the other side of the subject. And finally, this point light or spherical light, because it has a radius of, I think, about 0.5, which is placed near the backdrop object to make it a bit brighter. We can actually open up the light manager from the Arnold menu and take a look at these lights individually. First, let's turn off all the lights. Now if I enable the main light, you can see how this affects the lighting. You can turn it off and enable the backlight, then the front light, and finally the background light. You can check out the exact parameters for these lights. For now, let's turn them all on and close the light manager and change the viewport to the camera view again. Now select the dragon model and assign a new Arnold standard surface shader to it. We can zero out the base weight, as we don't need any base or diffuse contribution for this shader. The specular section can be adjusted as you wish, and depending on how reflective you want your final shader to be, it can be altered. In this case, let's set the specular weight to about 0.5 and the specular roughness to about 0.5 as well. Now remember that the specular roughness in the standard surface also controls the transmission or refraction roughness, so we need to take that into consideration when working with the transmission section of the standard surface shader. Before going to the transmission section and adjusting any parameters there, we need to disable the opaque option for the dragon model so Arnold calculates the transmission rates for this object properly and wouldn't consider it an opaque object. So select the model and from its shape and under Arnold section, disable the opaque option. Now we can get back to the shader itself and expand the transmission section. We need to increase the transmission weight to start making the shader refractive and transmissive, but not all the way to 1 because standard surface is an energy conserving shader, and setting the transmission weight to 1 disables the base and subsurface section. And in this case, we probably would involve the subsurface section later on in the tutorial. We discuss all of these concepts and much more in our comprehensive introduction to Arnold for Maya. You can check that out at MographPlus.com. For now, set the transmission weight to maybe 0.93, something like that. And now we get our glass-like shader. But we can transform this look using color, depth, scatter, and scatter anisotropy parameters to the look that we want. Transmission color here controls the color of the light when it passes through a transmissive shader. This filters the refraction according to the distance traveled by the refracted ray. The longer light travels inside a mesh, the more it is affected by the transmission color. Therefore, for example, green glass gets a deeper green as rays travel through thicker parts, a darker shade of green. Naturally, colored glass has different shade of color based on its thickness. Thinner parts will be tinted lighter and thicker parts will have darker shade of that color. In this case, let's select a light blue color with the RGB values of 127, 196, and 2110. Just kind of light blue here. A depth parameter controls the depth into the volume at which the transmission color is realized. Increasing this volume makes the volume thinner, which means less absorption and scattering. So if I start from a depth value like 1, you notice we get a very dark shade of this blue on the thicker parts and a lighter shade on the thinner parts. If I gradually increase this value to say 3, 5, 10, and 20, the contrast between the thin and thick parts become less and less, and in this case we can probably use a value like 3. Depth here is a scale factor so that you can set a transmission color and then tweak the depth to be appropriate for the size of your object and control how the transmission color affects the thick and the thin parts of your object. Scatter here allows you to simulate subsurface scattering for refractive objects and can be used to create shaders for high viscous liquids like honey, caramel, or chocolate, or surfaces like ice or polyson glass. So if we use any other scatter color than black, we start to get this transmissive subsurface scattery look. Let's try a few different colors so you can see how different colors affect the overall look. Now, if we try to use a harmonious and balanced color with our transmission color, we can get close to that dragon shader look that we want. In this case, probably a nice warm yellow color with the RGB values of 194, 107, and 11 should give us a nice balance. Scatter anisotropy here is the directional bias or anisotropy of the scattering. The default value of 0 gives isotropic scattering so that light is scattered evenly in all directions. Positive values bias the scattering effect forwards in the direction of the light, while negative values bias the scattering backwards towards the light. So as we are using a positive value in this case, we enhance the contrast and making the shader more transmissive than subsurfacey, and by using a negative value, the contrast between colors becomes less obvious and we get this look. In this case, probably something like 0.7. We can even render out two versions, one with 0.7, one with something like 0.9 to just add that extra contrast and flavor. And that's what we get, which is a very close render to what we want. this should be enough, but if we want to go a bit further, we can involve the subsurface section of the standard surface shader. For now, we can zero out the transmission weight and increase the SSS weight to about 0.5 and scale to maybe around 4. For the radius, I want to see more blue and green scattered beneath the object, so let's decrease the red to about maybe something like 50. Now we can see the result in the render. Blue and green are scattered way deeper compared to red, which is only visible in the thin areas of the geometry. Now let's increase the transmission weight to 0.93 again and wait for the render. And here what we get. When adding SSS section of the standard surface, the render becomes twice as long as before, and honestly the effect won't be that obvious if the transmission weight is too high. We can start decreasing the transmission weight to see more and more of the SSS effect, but in this case 0.93 is the perfect number. We don't want that much of SSS, and we probably can even disable it. Now, what if we wanted to alter the look and create a red jade shader or something like that? Well, we just need to adjust the transmission color and transmission scatter color. In this case, let's stop the IPR and open up the hypershade. And let me graph the material, select the dragon and graph the material on the viewport selection. Let me just simply copy this shader and assign it to the dragon model. And select the newly created shader. If we come down to the transmission section and run the IPR, and we can change the transmission color to a kind of dirty pink with the RGB values of 210, 104, and 138, and a light blue for the scatter color with the RGB values of 104, 138, and 210. And in the SSS section, we can decrease the weight to maybe about 0.35, and in this case I want the red values to go further beneath the surface, so let's set the radius color to 255 for red and about 80 for green and blue. And you can see the result in the IPR. Now, using the scatter and isotrope, you can get a wide range of looks. If I increase it to something like 0.9, we get this look that is more contrasty, and it has a more of a transmissive properties. For the final render, let's go to our render settings and set the camera samples maybe to about 5. Diffuse and specular samples could be about 3. The transmission is the dominant contribution of the shader, so let's increase the transmission samples to about 4. We have some SSS going on, but it barely contributes anything, so 3 would be enough. Now you can set your final resolution, probably 1280 by 720 would be enough for this tutorial. In the render view, make sure the resolution is set to 100% and progressive refinement is disabled. Now you can start the final render, and when it's done, simply save out the image from the file menu. You can download the finished version of this scene with the different variations that I make from this shader from the link down below in the description. Make sure to check out our comprehensive introduction to Arnold 5 for Maya at our website MographPlus.com. Share the video and subscribe to our channel. Thanks for watching. It was Kamel Khezri with you. See you next time. Thanks for watching this free video tutorial from MographPlus.com. If you are interested in learning Arnold 5 for Maya fundamentally, please make sure to check out our comprehensive introduction to Arnold 5 for Maya course, which is a massive 9-hour long course in which we explore all the aspects of Arnold for Maya thoroughly.